Alright, so what's the difference between the standard form of a line, which is the top one, and the function form of a line, which is the bottom one? Well, in the function form, you've got more parameters. There's a, b, h, and k. And in the function form, there's only a and b. From the function form, so this is function form. From function form, we can find the slope, and we can find the y-intercept. So, obviously, this form is preferable because it gives us more information, more useful information. However, it's not impossible to get a line that's given to you in standard form, which I'll call STD for standard form. So standard form, although it's not immediately obvious, you can also get your A, and it's just these two multiply to each other. And you can also find your y-intercept simply by letting x equal 0 and then solving for y. But what's the point of using standard form? Standard form is pretty useful if you're going to talk about parabolas, because what happens with a parabola is you take the basic function and it's got a vertex, and h and k will then translate the vertex somewhere else into the plane. So if I have h, I don't know, is 3 and k is 4, what happens is you're going to move 3 units to the right and 4 units up, and your new parabola is going to start up here. So h and k translates your parabola from its vertex. A straight line, however, doesn't have a vertex. It passes through the origin, that's the basic line. And if you have an h and k, what it does is it's going to take the point from the 0, 0, from the origin, and it's going to move that. It's going to move that point the same way it would move the vertex. So using h and k again as 3 and 4, what happens here is it moves to the right by 3 and then 4 up. And so what happens is now your line is now like this. It's still parallel. It's just moved from the origin to a new point. So h and k in a straight line is kind of useless because it just moves the line further away.